All right, algebra students, welcome back. Coach Spots here again. Just want to go through some practice problems in preparation for tonight's Ed Puzzle activity and homework. So I'm going to turn this video into an Ed Puzzle today. We can use some class time today to go through it, and then hopefully you can go back and watch this again over the weekend in preparation for the test on Monday. So we're going to talk right now about writing a linear inequality from a word problem. All right, so let's go to two basic level questions. Okay, 2 less than 3 times the number x is greater than or equal to 7. So in our inequality statement, one of the things I would do is look for our verb. Our verb is going to be the word is. Okay, and in an inequality statement, it's either going to be is, that would be an equal statement actually, is greater than, is less than, is greater than or equal to, or is less than or equal to. Here we have the words is greater than or equal to. That is our verb. That is where we put our inequality symbol. So our inequality symbol here is going to be the is greater than or equal to symbol. Obviously, on the right-hand side of that, that's pretty easy, 7. Okay? On the left-hand side of that, we've got a big chunk of stuff. Okay? We've got 2 less than something. 2 less than something. Okay? What is 2 less than? 2 less than 3 times the number x. So we've got 3 times the number x, and we're going 2 below that. Remember, this does not say 2 is less than, making it a verb. That would be wrong. This would be a wrong way of writing it. Okay? We do not have the verb is in there. 2 less than just means 2 below. Okay? Below means subtracted away from, meaning we're starting at 3 times the number x, and we're going 2 less than that, or 2 below it, or 2 being subtracted from that. All right? Our next example, the quotient of twice a number x and 7 is at least. All right, so is at least is our math verb here. Okay, at least means greater than or equal to, because it's at least something. So like if I say I have at least $100 in my bank account, then I have more than $100 or exactly $100 in my bank account. If I say I have at least $100, all right? So at least 6. All right, now let's look at the rest of the problem. Let's see what they talk about. The quotient, so that is the division symbol, okay? The quotient of, now we're going to look for the word and. And separates the numerator from the denominator. So here would be the numerator, 2x. And here would be the denominator, 7. Okay? So our final answer would be the quotient of twice a number and 7 is greater than or equal to 6. Watch that through a couple times if you need to. That might be beneficial. All right, we see the word quotient. We know that we're tying together 2 items. They're going to be separated by the word and. The first item will be our numerator. The second item will be our denominator. Hopefully that helps us. Okay? Now let's go through some symbols. Is less than is that symbol. Is greater than is that symbol. Okay? We typically always write x on the left-hand side of those. X is less than something. X is greater than something if we were to say that. And that's how we solve them. All right? So now let's talk through some symbols here. Okay? At most. I have at most $100. Okay, so I could have $99. I could have $100. I could have $1. I have at most $100. That means I do not have more. If the most I could have is $100, I could have less than that. So at most means less than or equal to, because I could also have that. Another way of saying that is no more than. I have no more than $100. I could have $100. I could have less than that. All of these are expressions for writing the phrase is less than or equal to. That's all the same symbol. Okay? if I say at least, okay, I have at least $100. I could have $200. That is at least $100. I could have exactly $100. That's why it's the or equal to. I have no less than $100. It's the same symbol. But I don't have less than $100. I have more than it, in fact, or I have exactly $100. Those all mean is greater than or equal to. Let me draw that a little better. Okay, are we good with this? These are not inequality statements. Let's talk about why they're not inequality statements. Because they don't have a verb. I do not have the word is in front of them. And because is not in front of them, okay, when I say more than, if I say 5 more than a number, ooh, that is really bad handwriting. 5 more than a number. What that means is start at the number and add 5. This is the same thing as saying increased by 5. This is not a verb. It's an addition symbol. It's a math operator. Okay, we're going above, or we've increased x by 5. If I say 5 less than a number, notice I am not saying 5 is less than a number. There is no verb in here. So we're saying we're starting with x and we're going 5 below that. These are not inequality statements. This is what we do when we write expressions, all right? Let's practice another one. The product of 7 and the difference of x and 3 is no more than 2. I'm going to let you guys try this right now on Edpuzzle. All right, I'm back now. Let's look at how to solve this. Okay, I'm going to look for my verb. That's the easiest thing to do first. Is no more than. Okay, no more than, meaning it needs to be below that. It needs to be less than or equal to that. Okay, if it says is no more than, we're talking about is less than or equal to. It could be equal to 2. It cannot be more than 2, but it could be below it. Okay? That's where I get that from. All right, let's look at the rest of this. We're going to look at the product. Let me use better color coordination here for those of you guys that are able to see this. The product of something and something else. So that separates our two ideas. So we have 7 times something else. So let's look at what the something else is. This is the second portion of the product, right? The product of 7 and a bunch of other stuff. Now this bunch of other stuff happens to be its own expression. Okay, it's a little bit of a trickier problem. But this bunch of other stuff has its own problem involved, where it says it is the difference or the subtraction of x and 3, right? The difference of x and 3. The subtraction of it. Now, we would not write it like this ever, because 7 needs to multiply to all of that difference, meaning we put parentheses around it to signify that 7 multiplies to all of it. Okay, so hopefully you were able to write this expression correctly. Okay, part 2. Now take this expression and solve it. All right, you should have solved it by now. So let's show how to do that. Distribute, we've got 7x minus 21 is less than or equal to 2. Add 21 to both sides. 7x is less than or equal to 23. Divide both sides by 7. Since we are dividing by a positive number, we do not have to flip it, the inequality symbol. Okay, and that's our solution. Okay. Now we're going to talk about how to find 2 consecutive integers. with greatest sum. What that means is we want the biggest two integers that fit the next situation. So we want to find, so imagine this was not there. Let's read this off together. Find two consecutive integers whose sum is at most 67. Okay, so we're saying we want two numbers that add up to be at most 67. Okay, well I can think of two numbers that add up to at most 67. I can think of the number 1 and 2. 1 plus 2 is 3, which is definitely less than or equal to 67. Because what does at most mean? Is at most means less than or equal to 67. We don't want it to be any more than 67. We want it to be less than or equal to 67. That's the most it could be. So technically, 1 plus 2 would work. Would you guys agree with that? Or I could say 3 plus 4, or 4 plus 5. Any of those numbers work. So technically, any of these consecutive numbers, consecutive means numbers in a row. They're integers in a row, so like 5 and 6 are consecutive integers. 10 and 11 are consecutive integers. 90, then 91, etc. Okay? I can pick a lot of combinations that add up to 67 or less. So that's why we add in these words right here. We want the greatest sum. So we actually want the specific two integers that add up to be the biggest combination we could. And the biggest combination would be adding up to be 67 in this case. Does that make sense? If it adds up to 67, that's the biggest it could be. So you're probably already in your head, oh, 33 and 34. Yes, that's the largest combination. Because if we did 34 plus 35, that would end up being 69, which would be too large. Okay? That would not be smaller than or equal to 67. But let's solve this mathematically. When we say consecutive integers, there's a algebraic way that we can solve these types of problems. We are going to assign each integer to be a different math unknown. The first integer we can just call x. Okay? We don't know what it is, but we know it's x. It's whatever. The second integer we know is the next number above x. It's literally just one more than x. So how do we say one more than x? X plus 1. So our equation becomes x plus x plus 1. And the simplified answer you should be putting in is 2x plus 1, which is less than or equal to 67. Okay? Here's the first answer, x. Here's the second answer, here's the first number, x. Here's the second one, x plus 1. Add them together, they need to be at most 67. So that's 2x plus 1 is less than or equal to 67. Now let's go ahead and solve it. Subtract 1. 2x is less than or equal to 66. X is less than or equal to 33 when I divide by 2. So that means, I know, x is less than or equal to 33. It could be any number below 33. It could technically be 1. It could be 7, because 7 plus 8 is 15. That works. But we want the greatest value, which would be 33. So our first answer would be 33. Our second one is 33 plus 1. Why did I get 33 plus 1? X plus 1. It's 33 plus 1, or 34, if you will. Okay? How does that sound? Everybody's good with that? Okay. I changed this problem up slightly. Let's see what I've done here. At least 180. So, greater than or equal to 180. That's the first thing I change. Well, I can think of tons of numbers that add up to above 180. Let's look at what this means right here. Now we're looking at 3 integers. Find 3 consecutive integers. We're looking at 3 of them. However, the specific 3 that we're looking at, we need to be even integers, meaning 22, 24, and 26. Those are consecutive even. 36, 38, and 40. Okay? Think that through. 102, 104, 106. They're the very next even numbers. Okay? Meaning, whatever we choose for our first even number, x, our second one is going to be 2 above that. And our third one is going to be 2 above that. So x plus 2 plus 2, which is really x plus 4. Okay? Well, we can think of plenty of combinations of 3 integers that add up to be more than 180. I got one for you. 1,000, 1,002, 1,004. Add them up, they're bigger than 180. That's why it says we want the smallest ones. We want the least sum. So I'm just going to add these 3 ideas together. X, that's the first one, plus x plus 2. That's the second one, plus x plus 4. That's the third one. I simplify that equation to 3x, because there's 3 of those x's, plus 6, because that's what 2 plus 4 is. It needs to be greater than or equal to 180. All right, and now I'm going to solve. Okay, 3x is greater than or equal to 74, because I subtract the 6 over. Sorry, 174, because I subtract the 6 over. Divide by 3. X is greater than or equal to, I don't know, what is that, like 58? So now that we know 58 or above is our x values, we want the smallest one. 58 is our first number. That means 60 and 62 are our next 3 numbers, our next 2 numbers. Okay? If you add this up, that is exactly 180. So this is the smallest combination of 3 even numbers that add up to at least 180. Okay, let's highlight some more word problems. So if you notice today, I'm going through word problems that should help you for the test. So read this. All right. There are 94 kids in my lacrosse program. I split them into groups of 9, and there were 4 kids left over. Write an equation for this scenario and solve to find how many groups there are. First off, this is not an inequality problem. That's the first thing I want you guys to understand. This is not an inequality problem. Okay? Write an equation. Okay, so that means there's going to be an equal sign, not an inequality symbol. Okay? And it equals a total of 94 students. Or 94 players on my lacrosse program. And I had split them into groups of 9, and there were 4 kids left over. So the plus 4, that is the extra kids left over. Groups of 9 times the number of groups we have. Right? X is the unknown. That's how many groups are there? I don't know. There's 9 kids per group times the number of groups. Add 4, and that equals 94. So here is our equation. Okay? Solve this out. Subtract 4. We get 9x equals 90. Divide by 9, x equals 10. So there were 10 groups of 9 kids, that's 90 players, plus the 4 left over. That works for our problem of 94. Okay? That's an example of a word problem that you could see on the test that's not an inequality statement. Okay? Now we're going to look at one that is an inequality statement. Okay? I have 230 candy bars. I want to give 3 candy bars to each student in all my classes. There are at least 20 candy bars left over at the end. How many students are in all my classes? Question mark. We are going to actually make sure that we write an inequality statement first. So we must have an inequality statement first. Okay? Must have that. I have 230 candy bars. I want to give 3 candy bars to each student in all of my classes. There are at least, I know we said look for the word is, but the word are happens to be one of the, I'm not an English teacher, so I don't know the word for it, one of the forms of the verb to be, okay? I think it's one of the conjugations of the word to be or is, etc. So are at least is greater than, that's that symbol, 20. So we see that is going to be part of our inequality statement. Now, how much did we start with? think this through, guys. How much did we start with? Boom. 230 candy bars. What are we doing with those 230 candy bars? We're giving them away. We're giving them away. We're taking away from 230, and what's left over is at least 20. In fact, right here it says, I want to give 3 candy bars to each student. Give 3 candy bars to each student. We are taking away from this 230 candy bars, we are taking away 3 candy bars per kid. So the left-hand side says we started with 230 candy bars. I'm taking away 3 per kid, and what's left over is at least 20 of them. This is our inequality statement. Boom, this problem is done as far as writing the inequality statement. On the test, half of your credit for the problem will be correctly writing an inequality statement. That will be half the problem. So if you don't have it set up, you're going to lose some points. Now there's other ways we could rearrange this, but this is the best way based on the wording. Now let's go through and solve this. Okay, so we've got 230 minus 3x. You know what? Let's subtract 230 from each side. I know that's going to get ugly because we're working with negatives, but it's going to work out. We're going to subtract 230 from each side. That leaves me with negative 3x on the left side, because it's still negative, okay, is greater than or equal to. Notice I don't flip the sign from subtraction. Negative 210, okay, because 20 minus 230 is negative 210. Now, just like we would solve in the past through dividing by this coefficient, the coefficient of negative 3, the difference now is when I divide by a negative, I have to take this inequality symbol and flip it. That is part of the rules if you watched my previous YouTube videos. So we will now have is less than or equal to, because I have flipped this inequality statement. So now I have x is less than or equal to, negative over a negative cancels out. 210 divided by 3, I believe, is 70. X is less than or equal to 70. So, what does that mean? I had 230 candy bars. I wanted to give 3 candy bars to each student. There's at least 20 candy bars left. So here's what that means. If we had exactly 70 students, we would have exactly 20 candy bars left over. That's the or equal to portion of this symbol. But I could have less than 70 students. What if I only had 60 students? Then I would have more than 20 candy bars left over. That makes sense. Look at our symbols. It lines up. I could have less than 70. I could have had 70 because I could have or equal to. Or I could have less than that, so I could have 60. Okay? If I had 60 kids, I would have more than 20 candy bars left over. All right? Might want to watch through this again. Okay, now let's look at another problem. I currently have $870 saved for a new car. I can earn up to $1,000 per week. Okay, that's a little misleading. Up to $1,000 per week looks like it's the inequality portion. It's not, but just keep in mind we're going to want to max that out. We want to maximize our money each week. If we can make up to $1,000 per week, let's do that. Okay? Currently start with $870. This is the question that now has our inequality statement in it, even though it's hidden. It says, how long will it take to have 16,500? We're assuming we want at least 16,500 to buy the car we want. If you have more money than you need, that's okay. Trust me, okay? We want at least $16,500. We started with $870, and we can earn $1,000 per week. This is our $1,000 per week plus our starting $870. So this is our inequality statement. So on the problems, when it asks for what is the inequality statement, this is what we would write. Now we can go ahead and solve this. Okay? How would we solve it? subtract 870. Oh no, I have not done this yet, and I don't have the answer in my head. 1000x is greater than or equal to, was that 370 more than that? So $15,630. Okay, we want this to be bigger than that. Divide by 1,000. You're going to get x is greater than or equal to 15.63 weeks. Well, guess what? You can't have 0.63 weeks of money yet, okay? So we're going to actually round this up. We're going to look at this and say, I want at least 15.63 weeks worth of work. Okay, so if we're answering this now, they gave us the problem as a word problem. We might have to answer this as a word problem. So x equals at least 16 weeks. It's going to take you 16 weeks to get enough money. In fact, 16 weeks will get you $16,000 if you're making $1,000 a week. So 1,000 per week times 16, $16,000 plus 870. That gives you what you need. Awesome. My screen, my computer just. Okay. Technology outages everywhere here. We are digitally learning, and yet the power goes out. Thankfully, it came back on. Thankfully, my computer was still plugged in. Or not plugged in, it had battery. Okay. Okay, practice problems. Go ahead and do this now. I'm going to have you guys work on this on Ed Puzzle. Boom, go. Okay, you're back. Let's see if we got this right. Is at least. That's what I'm looking for first. So greater than or equal to 7. That is the is at least. Twice. Okay, twice what? Twice the sum. So we are adding two ideas. When it says the sum of something, we're looking for the word and. And separates the two ideas that we are adding up. We're adding up x and 3. This is the sum of x and 3. And we're doing twice that entire sum. So the way that we would do twice an entire sum looks like this. Okay? Where we multiply the entire sum by 2. All right, now I'm going to have you solve this. Okay, you're back. And probably what you did was distribute. Okay? Subtract 6 from each side. 2x is greater than or equal to 1. X is greater than or equal to a half. Now, let's graph this on a number line. If we had a number line, here's 0, 1, 2, 3. Well, guess what? Here would be 1/2. In fact, these could be all of the hash marks for halves. Okay? And we want to be a closed circle at 1/2, shaded to the right. Because we could equal 1/2, it's or equal to, but we probably want it, or it could be bigger than that. Okay? Another example right now. I'll have you guys solve this. Okay? 3 less than the quotient of a number x and 2 is at most 17. Let's go for our is at most. Is at most 17. That means less than or equal to 17, because that's the most that we would be happy with. It is at most 17. 3 less than. Okay, so in some capacity, we're subtracting 3 from something. We're subtracting 3 away from something. What are we subtracting it away from? A quotient. Quotient of something and something else. And remember, the first value, that's our numerator. The second value, that's our denominator. So this is 3 less than, 3 taken away from or below or subtracted from the quotient of x and 2. Boom, there we go. Now let's solve this. Add 3 to each side. We got x over 2 is less than or equal to 20. I totally just thought this board was shaking big time. It was my stomach growling. You know it's bad when you work all day and you don't eat, and then all of a sudden it's like 2 or 3 o'clock in the afternoon, you haven't eaten at all day. All you've done is emails and teaching and live instruction on Zoom and digital stuff like that, and then you're prepping more digital lessons for the next day. You haven't eaten, and it's all of a sudden, boom, that hunger strikes. Okay, so I'm going to multiply by 2 to each side, and I end up with the final statement: x is less than or equal to 40. Okay? All right, go ahead now and answer this one. Find 2 consecutive integers of greatest sum that is at most 183. All right, we're not going to do this one as an ed puzzle. I want you to try to write it down right now and then work it out, and then I'll come back in and solve it. Okay, hopefully that was enough time to work through it, at least to just figure out what's going on. Where it says is at most, talking less than or equal to 183. All right, at most. Find 2 consecutive integers. So once again, our first integer is going to be x. Our second integer is going to be, let's see, are they even? Nope. If they're even or if they're odd, they're 2 numbers away from each other. So it would be plus 2. But they're not. They're just consecutive integers like 79 and 80. So they're 1 number away from each other. So our second number is just going to be x plus 1. Okay? So when we add those together, that's 2 x's plus 1 constant. Needs to be less than or equal to 183. Solve this out. 2x is less than or equal to 182. I just subtracted by 1. Now I'm going to divide by 2. X is less than or equal to 91. So that means the first number is 91, second number is 92. And let's check that. 91 plus 92 equals 183. That works. In fact, I just wanted it to be less than or equal to 183, so I could have done any 2 numbers I wanted that's less than that, so like 5 plus 6 would work, except they want the greatest combination that we could find. So the greatest combination was 91 and 92. So the answer, I just wrote it wrong. A little dyslexia there, wrote 19 instead of 91. 91, 92. Okay? One more. This is a long video, guys. Sorry about that. Okay. Go ahead and work through this now at this time. I currently have $75 saved for a new pair of shoes. Each day I can earn up to $13 per day more. Okay, so $13 per day plus the $75 I currently have, and I need to have at least $120, right? Because I want to have enough money for the shoes. So I need at least $120. Okay? Solve this out by subtracting 75. So 13x is greater than or equal to, I don't know, what is that when I subtract? That's 75 right there. What is that, 45? Okay, 120 minus 75 is 45, I hope. Divide by 13. You're going to get a decimal for this. X needs to be bigger than or equal to 3 point something. I guess I'll just do this on my calculator right quick. 45 divided by 13, 3.46. Okay, so X equals at least, what was this, weeks or days? Days, at least 4 days. Okay, it will take you at least 4 days to get that much money. Oh, I actually had one more problem. Look at this. This one's going forever. Okay, Jimmy has $50, but he saves $10 per day. So right now, Jimmy, we'll do Jimmy on this side of the equation. $10 per day plus 50. And Ted has $80, but only saves $5 per day. So $5 per day plus the $80. Okay? How many more days will it be till Jimmy has at least as much as Ted? So we want Jimmy to be at least as much as Ted. Here's Jimmy, at least as much as Ted. Press pause if you need to think this one through for a while. Okay? Now we want to solve it all out. So I'm going to move this 5x over there by subtraction. Okay, that's gone. This becomes 5x. Move this 50 over here by subtraction. Keep the inequality symbol. We're now at 30 on this side. X needs to be bigger than or equal to 6. It takes 6 days until Jimmy will have at least as much money as Ted. After 6 days, he has way more. But up until like days 1 through 5, Jimmy has less than Ted. Day 6, they have the same amount. At least day 6, it takes 6 days till he has at least the same amount. After that, he has way more. That's a long one today. One pass, no edits, 37 minutes of video. Holy cow. Sorry, kids.